Given the rational function here, we want to find the domain of the function, then complete the table of values and graph the function. And for this video, we will be using the graphing calculator for assistance. To determine the domain of a rational function, we want to find the values of x that we must exclude from the domain, and since division by 0 is undefined, we want to set the denominator equal to 0 and solve for x to determine the values of x we must exclude. So we'll set x squared minus 4 equal to 0. This is the difference of squares, so we'll factor this into the quantity x plus 2 times the quantity x minus 2. So our solutions are x equals negative 2 from this factor, or x equals positive 2 from this factor. So the domain would be all real numbers except x equals plus or minus 2. So we can say positive and negative 2 are zeros of the denominator, and since they're not zeros of the numerator, that means we have vertical asymptotes at x equals 2 and x equals negative 2. If they were also zeros of the numerator, that means we'd have a hole in the function rather than a vertical asymptote. So we have a vertical asymptote here and here. Remember, these are vertical lines that the graph will approach and never cross. So they're very helpful for sketching a graph. We'll also use these excluded values to help set up this table. We'll go ahead and put negative 2 here and positive 2 here. Now we'll select values that are less than and greater than these two values of x. So here we'll select values that are less than negative 2, and it is helpful to have values of x that are close to these excluded values. So let's go ahead and use negative 2.5, negative 3, and negative 4 for values less than negative 2. And for values greater than negative 2, let's select negative 1.5, negative 1, 0, 1. And then for a value close to 2, let's select 1.5 and 2.5, 3, and then 4. And we already know that at negative 2, the function is undefined, as well as at positive 2. And now we'll go to the calculator to help us complete this table. So we'll first enter the function, so we'll press y equals. Notice how I've already typed in the function. Notice how we need parentheses around the entire denominator so the calculator reads this correctly. Now before we complete the table of values, let's take a quick peek at the graph. So we'll press zoom 6 for the standard window. We can see the rational function has 3 pieces because of the 2 vertical asymptotes. And now we'll use the table feature to complete this table. So we're going to press second window to set up our table. Let's go ahead and start at negative 4. Instead of the change in the table being 1, notice how I changed it to 0.5 because we do have some decimals here. We want the independent option to be automatic. And now we'll press second graph for the table of values. Notice the y values or function values are decimal approximations, so we'll go ahead and round to 2 decimal places when completing the table, which can be helpful for graphing. Notice when x is negative 4, y is equal to approximately 0.67. X is negative 3, y is 1.6. At x equals negative 2.5, it's approximately 3.56. And at negative 1.5, it's approximately negative 4.57. Scroll down. At negative 1, it's negative 2.67. At 0, it's negative 2. And at 1, it's negative 2.67. At 1.5, it's approximately negative 4.57. And at 2.5, it's approximately 3.56. And then at 3, it's equal to 1.6, and at 4, it's equal to approximately 0.67. Notice how you do see some repetition of the y values or function values, and that's because of the symmetry of the graph. So now I'll go ahead and plot these points and sketch the function. Let's start with the leftmost piece of the function. So we have negative 4, 0.67, somewhere in here. Negative 3, 1.6. Negative 2.5, 3.56, somewhere in here. And now we have the values between negative 2 and positive 2. So negative 1.5, negative 4.57, somewhere in here. Negative 1, negative 2.67. 0, negative 2, our y-intercept is here. 1, negative 2.67. 1.5, negative 4.57. And then to the right we have 2.5, 3.56. 3, 1.6. And 4, 0.67, somewhere here. So again, we rounded some of these values, but often it's easier to graph decimal approximations. Now there is one more thing to mention here. As the function moves to the right, or as x gets larger and larger, notice how the denominator also gets larger and larger. So 8 over a larger and larger number is actually going to approach 0. The same thing is true as x decreases to the left. To see what's happening here, let's go back to the calculator for a moment. So from here, if we just press the down arrow, x will increase, and we can see what happens to the y value. Notice how it's getting smaller and smaller, and it's approaching 0, which means we'd have a horizontal asymptote of y equals 0. And the same thing would happen as x decreases to the left. So we also have a horizontal asymptote of y equals 0, which again is also helpful to sketch the graph. But it is possible for a rational function to cross a horizontal asymptote, but not a vertical asymptote. So our graph would look something like this. Piece on the left, this piece in the middle, and we have this piece on the right. And again, we had a horizontal asymptote of y equals 0, vertical asymptote at x equals 2, and x equals negative 2. Okay, I hope you found this helpful.